One of the critical aspects of IoT devices is to be able to not consume too much energy. Tyler Fox from the Azure Sphere team is here to present a new feature called Power Down to make exactly that happen on Azure Sphere devices. It's today on the IoT Show. Hey everyone, you're watching the IoT Show, and I'm Olivier. Thanks for joining. Today we're going to talk about low power scenarios with Azure Sphere, and I have Tyler Fox with me. Tyler, thanks for joining the show today.
Thanks a lot for having me. Glad to be here.
So Tyler, for our audience, give us a short introduction of yourself and what you're doing in the Azure Sphere OS team.
Sure. So I'm a PM on the Azure Sphere OS team. I'm responsible for the kernel, power, performance, storage, error reporting, diagnostics. So I wear a few different hats, but today I'm wearing the power hat. I'm going to talk about power management on Azure Sphere devices.
I like I wear the power hat. You have the power. Love that. So power management and power consumption for IoT devices is critical, but let's extend a little bit on that topic. Why is it that important for IoT scenarios and devices to have proper power management and to have the ability to go down in power consumption?
Yeah, so there are many IoT devices that need to operate in power-constrained environments. So there are a lot of times where a permanent power source isn't an option. From door locks, remote sensors. There are a lot of devices that are often powered by batteries, solar panels, or even sometimes supercapacitors. And of course, for these types of equipment and devices, power consumption is really important. So these are often critical deployments that customers want to protect and connect while operating on a minimal power budget to create long-lasting devices that will overall reduce the cost of maintenance for the lifetime of the device. And in short, we want customers to have high security and low power capability.
Easy. Security, but low power. And we'll talk more in details about exactly what that means. How is Azure Sphere providing capability of going very low in terms of power?
So we have a new state for Azure Sphere devices called Power Down. And Power Down is the lowest possible power state that an Azure Sphere device can enter, short of being physically disconnected from a power supply. So this means that everything is powered off except the real-time clock, or RTC for short. So your CPU cores, your RAM, flash, connectivity, everything is powered off. So you can achieve maximum power savings. And on the MT3620, our current Azure Sphere chip, you can configure it to draw as little as 10 microamps when in the power down state. So you'll see anywhere from 10,000x to 50,000x reduction in power consumption compared to normal operation. And then when you're in the power down state, the second thing is that devices can be awoken either after a specific amount of time, when this real-time clock alarm fires, or from an input signal triggering a GPIO wake-up pin. And then finally, there's no state preservation in power down. Because you're turning off RAM and everything, waking up is equivalent to a cold boot.
Okay. So let's talk about the scenarios. So I understand the feature at a high level, right? So you can put it down. Everything is shut down pretty much. There's still the wake up GPIO pin, but we'll see that in more details. How do we expect customers to use, what kind of scenarios do we see customers using that feature?
Right. Power down is most useful for minimizing power consumption when a device is at rest for long periods of time. And there's kind of two classes of devices you see that will benefit the most from power down. Devices that want to do time-based wake up or event-driven wake up. So for the former, take, for example, a device that needs to read data from a sensor and then upload the collected data to the cloud twice per day. This is a great scenario for power down because you can stay dormant, powered down in this low power state for the majority of the day and then just quickly wake up, take your measurement, upload it to the cloud. And you may remember our example, of a cactus watering sensor from a previous Azure Sphere episode of the IoT Show with Ed Nightingale, the director of engineering.
Yep.
Right. So, the cactus watering sensor could take advantage of power down too. And, it could enable you to deploy your cactus wherever you want, free from power outlets, and even move your cactus around.
Yeah, and actually let's talk numbers because to me, it seems like as someone coming from embedded, it seems like the Azure Sphere devices very often, like the MT360, they're pretty beefy machines, right? Even for the IoT and the MCU space. So, like, let's talk numbers. Like, in that specific scenario of the cactus watering system, what is the difference between one that would be running without power down and one running with power down scenario?
Sure. Yeah, that's exactly right. In the MCU space, once you're adding multiple cores like the MT3620 has, as well as Wi-Fi and other and connectivity like that, you're going to have, be consuming a fair amount of power while you're doing work. So if you take this cactus watering sensor example, say you connect a couple AA batteries to your Azure Sphere cactus watering sensor, and you want to read the amount of water present in the soil just once per day, and then send it to the cloud using a service like Azure IoT. So you may have burned through your 2 AA batteries in just 9 hours before if you left the MT3620 just idling the whole time. But instead, if you were to use power down in between daily readings, you could go then, about 600 days or more before having to change the 2 AA batteries, just with a few assumptions, like you need 30 seconds a day for the reading, and then you also want to account for around 10 minutes a month for updates. So, going from 9 hours to 600 days is a pretty big difference.
It is pretty impressive, actually. And actually, well, for that cactus scenario, you might not actually even need to send to the cloud a reading every day, right? So is there a maximum time? Is there some limits in terms of putting that device in power down?
Yeah, that's a good question, right? You may not need to take daily readings. That was just a single example. So we tried to provide as much flexibility as we can for developers because we know that every scenario is different. So no, there's no minimum or maximum amount of time that a device can remain in power down. It's just down to your app and other constraints for your scenario, like battery life. I guess the only constraint would be, that the number of seconds in the program model, which we'll get to a little later on, is a 32-bit unsigned integer. So, however much you can fit in that, 100 and something years, 140 years around there. Yeah. But no, so practically speaking, there's no limit. So waking up more frequently will consume more power, which might be necessary for some scenarios. And, conversely, waking up less frequently will consume less power, but it's totally dependent on the scenario.
I see. And actually, you can leverage, you were mentioning the wake up, like GPIO. So you can actually have a scenario where you put it down like for a long period of time, and then you can wake it up on a physical event.
Yeah, that's exactly right. So like I mentioned, event-driven wake-ups is another great scenario for power down. So you can connect to the GPIO interrupt, wake-up pin, anything like a motion sensor, an inertial measurement unit, or even a GPIO line from another MCU. So, going back to the cactus watering sensor example, maybe you have a fancy moisture sensor that can send a GPIO interrupt if the moisture level ever exceeds a certain threshold. So this way, if you ever overwater your cactus and risk drowning it, let's say, the sensor could actually wake up Azure Sphere to record a measurement and send you notification that you need to save your cactus, right?
Yeah, totally. Well, talking about hardware, so there's actually a need to better understand, I guess, for our audience, how they're going to implement that power down, both from the hardware perspective and software perspective. So let's look into how Azure Sphere, both from the hardware perspective and software perspective, will be used to implement that power down.
Yeah, that's exactly right. So power down is a unique feature in that, there are both hardware and software considerations that you'll want to take into account. So starting with hardware, on the MT3620, there are 3 pins that are important for power down. So the first one is PMU-EN. And this is just a pin you'll need to tie low before devices can enter, to enable MT3620 devices to enter power down. And this is just a good hardware security feature, right? To make sure that an app can't put a piece of hardware in power down, basically turn everything off unless it was specifically configured to do that. The second pin that's important is EXT PMU-EN. So this is actually an output pin that is high when the device is awake and low when it's in power down. And this is super useful because you can, first of all, you may want to connect it to your other peripherals or parts of your system, maybe sensors or something, so that you can turn them off too when you go into power down, so you can save even more power from, connected peripherals. Also, most times when you use a chip like the MT3620, you'll need a voltage regulator to feed in power to the chip. So in this case, you might also be able to connect this this pin back to the voltage regulator to turn the regulator off, and so you'll save power from the that the regulator would otherwise be consuming, but also you'll basically have cut the power supply directly to the chip. So this is how you get in this lowest 10 microamp state that I mentioned before. And then finally, there's the wake up pin. And this is the input pin you connect to the GPIO to wake it up from an event, like I mentioned.
Yeah, seems to be pretty straightforward to me, at least from what I remember of my electronics and others. But how does it look like from the developer standpoint? Right, you're in your application, you have a flow in your application, a process, and so on. How do you control power down from software?
Right. So there's also a software aspect to this, like you mentioned. So the Azure Sphere OS provides a simple programming model to make it as easy as possible for apps to take advantage of power down. So the first thing you want to do is make sure that you have the power controls capability declared in your app manifest with the forced power down value, like you see here. So this is a really important thing that adds additional safety and security, and ensuring that only designated apps that were designed for power down can power down the device, right? You wouldn't want either a mistake or a rogue app or something to be able to power down and basically shut down your device unless you've specifically designed it to do that. And then once the capability is declared, it's really pretty simple. You just call the power management force system power down function you see, and from our new power management application library, and that will put the device in the power down state. You just pass in the number of seconds for the device to stay in power down. And then after it transitions to the power down state, it will wake up either after the specified amount of time, or if you trigger the GPIO wake up pin, whichever comes first. But using the wake up pin is totally optional. You don't have to connect it to anything if you just want to do time-driven wake ups.
I do like the fact that you're actually mentioning the fact that applications need to have the ability in the Azure Sphere context to access this feature and functionality on the Azure Sphere, because that actually reminds me that Azure Sphere is all about security. And actually, it brings a question. So device is down. However, one of the claims for securing IoT devices is that we need to keep them updated. And the Azure Sphere OS comes with the Azure Sphere service, security service, allows to automatically update your device to keep it secure and safe. So how does that work? How do you have, at the same time, power down and the ability of updating the OS of the Azure Sphere device?
Yeah, that's exactly right. So with Azure Sphere, security is always the number one priority. We want to make sure we are securely connecting as many IoT devices as possible. So to do that, Azure Sphere automatic devices, they automatically get security updates and improvements from Microsoft security experts through the Azure Sphere Security Service every month. So device manufacturers can use the same service to remotely update their applications on devices whenever they need to. This includes updates that OEMs make to their real-time apps as well. So like you said, it's really important to keep updates in mind when building apps that use power down. We tried to make this power down as flexible as possible, so you can power down whenever you want for however long you want. But with that in mind, it's kind of one of those things where with great power comes great responsibility, right? Yeah. So you want to make sure you're taking updates into account. And so we've tried to make this as easy as possible. So in short, your app can register for notifications about the update process. When the update check completes and your app sees no updates are available, when an update has started downloading, and when an update is finished downloading and is ready for install. So your app can track the progress of the update mechanism, and then use these notifications to make decisions about when it's safe to power down and when you should stay awake for an OS update or app update to download and install.
Yeah, I think you had a diagram that was describing the app lifecycle that actually goes into details about what you just described, right?
Yeah, right. So, the life cycle of a typical app that uses power down will basically look something like this in most cases. So, you see in the upper left, the app will start and begin performing its task. This may be, business logic, interacting with peripherals, reading a sensor, controlling some device, maybe uploading data to the cloud, probably a combination of those things. And then depending on how long that work takes, the device will either then immediately enter power down, or occasionally it'll want to keep it awake a bit longer to wait for the update check to complete using those notifications I just talked about. So once the app then decides, it's safe to power down, the OS will issue a SIG term to all running apps. So this will give them 2 seconds to clean up and gracefully exit if they handle the signal. And then the device will enter power down until the RTC alarm fires or the wake up pin is activated, whichever comes first. And then the device will wake up again, the app will start, and the cycle will repeat. And we provide a power down sample app that is definitely a great place to get started, that demonstrates how to do this safely and implement this life cycle in your app.
Yeah, nothing better than copy paste from a good sample, right?
Exactly.
So, while talking about getting your hands dirty with code and others, I think the first thing that lots of our audience will do, especially if they already have an MT360 device or some other Azure Sphere device, is put a meter behind to really see if our claim or your claim today, in terms of the power consumption reductions by using the mode, is effective. So, like, let's see how that looks like. You have demos, you have a couple of things to show here. Let's save some time for people who might doubt that we are able to reduce consumption that much.
Sure. So Stuart Taylor, a hardware engineer on our team who has access to 2 multimeters, was kind enough to record a quick video for us. So I can show you the dramatic difference that PowerDown makes. So here you'll see 2 Azure Sphere reference boards, development boards that are connected to multimeters showing their current consumption. They're both running a really simple app that essentially blinks a red LED for 10 seconds. The difference is that after the blinking finishes, the device on the left will enter PowerDown, while the device on the right will just sit idle. After 10 more seconds, both devices will start blinking the red LED again. So let me show you what this looks like.
Okay.
So you'll see that both boards start off blinking the red LED, and they're both drawing. The multimeter here is showing current consumption in amps. Sorry. So you'll see they're both drawing around 100 milliamps, and then now the one on the left has gone down to just 2 milliamps, whereas the one on the right is still drawing about 100 milliamps. And I want to mention that it's important to note that the one on the left is still drawing 2 milliamps. The reason for that is that the reference development board wasn't originally designed with PowerDown in mind. So it contains additional protection circuitry that draws about 2 milliamps of additional current. The MT3620, like I mentioned, can actually be configured to draw as little as 10 microamps on PowerDown, which is what will enable you to build all the power-constrained devices for the scenarios we discussed earlier.
That's interesting. And so another thing you mentioned that actually is still in the video here, it was pretty impressive, is that you mentioned that the power down is pretty much like it's a cold boot after. There's no state, they conserve and whatnot. But here we see on the scenario the 2 devices basically restart blinking pretty much at the same time, right?
Yeah, exactly. So as you saw, when they started booting up, that means in that time, when the device on the left woke up, we were booting the entire Azure Sphere OS, starting your app, and getting you back to doing your normal business logic in just a couple seconds.
Yeah, which actually is key to really be able to implement this kind of power down scenarios and still keep the devices on time when they have something to reach and meet. I think you have another demo, the one that you're going to code a little and show us a bit more of that, right?
Yes, I have a demo that I can do live to show you a bit about how you might use PowerDown for a scenario. So if you look here, you can see there's a schematic on the left and a picture on the right. So I connected an accelerometer to an Azure Sphere development board via I2C, and I wrote an app that's running on the Azure Sphere device. It basically reads the vertical acceleration from the accelerometer and uploads it to Azure IoT Central and then powers down. So for this demo, it'll stay in power down for 20 seconds, but normally you'd set this value for 24 hours, for example, if you want to do readings daily. I also configured the accelerometer to drive an interrupt pin low. So you'll see that here as int1 connected to the wake up pin of the MT3620. So that will allow us to wake up the Azure Sphere device with a tilt to demo the event-based wake up functionality. So how about we switch to the demo and I show you how this works. Okay, so I'm going to connect the Azure Sphere development board to a power source. And now I'm going to hold the MT3620 in reset, and this will stop it from drawing power. So you'll see the current meter still shows 0.05 amps or 50 milliamps while the SoC is in reset. This is just a quick informal reference measurement to show that even when the MT3620 isn't drawing power, the development board still consumes about 50 milliamps due to other things on the board like an FTDI chip and LEDs. Normally, again, you'd be able to turn these things off or not include them in a production design. So I also just want to note that the reason you only saw 2 milliamps of additional current in the previous video is that Stuart, our hardware engineer, actually modified that board in the video to connect EXT-PMU-EN to the 3.3 volt regulator, so that would turn off when the device powered down. And then he measured the current consumption directly on the 3.3 volt rail. But for now, since this current meter is connected over 5 volt USB, just know you can roughly subtract this 50 milliamps from the reading you see to get a better approximation of actual MT3620 current consumption. The broader point is that while the reference development board is great for software validation, development boards are typically not a great way to validate actual power performance. So let's let go of reset and start the app. So you'll see that the device will now boot. You'll see waking up on the terminal, and it'll read an acceleration from the accelerometer. So you see, about 1G because it's sitting on the desk. And during this, it's drawing about 150 milliamps, as you can see on the current meter here. And it's waiting for network, and now it's connecting to Azure IoT. This is because this takes a second because the device has to go through device authentication and attestation to obtain its client certificate from the Azure Sphere Security Service, which it needs to securely connect to Azure IoT. So now you can see this. Yes.
There's one important thing. In all our demos, we always systematically send every single telemetry data to the cloud when it comes in the device. But in real life, actually, you might not need to do that, right? Azure Sphere will allow you to eventually create some logic on the app itself that will only send data when needed, whether it will buffer the data, whether it will only send alerts. You don't need to send every single telemetry data in the cloud for things to work.
Yeah, that's exactly right. One great way to extend battery life further, or whatever your scenario may be, to reduce power consumption is to take readings, and then maybe if the reading's okay, only connect to the cloud when there's an important reading that you want to send immediately, or otherwise you can just batch readings, and the more the less frequently you have to upload data to the cloud, I think the less power you'll consume. So yeah, that's a great point.
And you can see the data arrived in IoT Central up there.
Yep. And so now you'll see these readings that have been going through, the data has now arrived in IoT Central. So you can see our vertical acceleration of 0.99G. And now the device is powered down, and you'll see it's back down to that 50 milliamps that you saw in reset when the SoC wasn't consuming anything. So that's that 10 microamps that this current meter can't really pick up because it's too small. So now if I'm going to just, it'll wake up and go through this cycle one more time. And then we'll try an event-based wake up with the accelerometer interrupt. So here it is again, waiting for the network. We'll do one more data point here, connecting to Azure IoT. And again, this is this attestation service that it's going through right now to get its client certificate from our Azure Sphere Security Service. This is a really important way that we make sure devices are always secure and up to date before connecting to the internet. So your service knows that any device connecting is secure. So here we go. Now it's powered down. But now this time, instead of waiting the full 20 seconds, if I just tilt the accelerometer like this, it's going to wake up immediately and take the reading again. So if I just kind of hold this here, just to get a different reading, you'll see it prints out tilt to wake detected. The vertical acceleration is now different, right? Because I'm tilting it sideways. It's not just sitting on a table anymore. We'll wait for the network one more time, and then we'll upload that newest reading to IoT Central, and as well as the tilt to wake event.
That's a pretty straightforward demo. I like that kind of demos.
Yeah, it's just a quick way, and I picked an accelerometer here because, it's the most configurable sensor I had here at home. But again, you can connect whatever you want here, right, for your scenario, whether it's a GPIO line from another MCU or any other type of sensor or some external peripheral you would want to wake up an Azure Sphere device. So now you can see if we look at IoT Central, you'll see, here's the much lower negative 0.04 reading from the tilted one, and as well as our tilt to wake event. So we know that the device was woken up by a tilt and not just on the normal timer.
Awesome.
So, yep, that's a quick demo showing you how to use power down with time-based and event-based wake-ups. So you can use Azure Sphere in power-constrained IoT scenarios.
So Tyler, Power Down is just one of many features that the Azure Sphere OS team is working on. So tell me a bit more about what's to expect next for power management on Azure Sphere.
Yeah, sure. So Power Down represents an important first step to enable many new power constrained scenarios for Azure Sphere. But of course, we recognize there are all sorts of power scenarios that are critical for our customers. And we're definitely committed to providing more flexibility and options for power management when building and deploying Azure Sphere devices. It's also really important for our team to be able to understand customer needs and provide new features and capabilities that address them. So we'd love to hear from your audience about specific power needs they have for their IoT devices and deployments. And it'd be great to get this feedback in the comments on this video or on the blog post that we'll link to at the end.
Cool. Where can they get started? Because yes, they can answer comments there, but they want to get to that sample you mentioned.
Yes, that's right. So I think the best place to start is with the Power Down sample app in our Azure Sphere Samples GitHub repo. Like I mentioned, the sample is extremely important because it shows how to make sure your app follows the correct lifecycle and is still able to check for OS and app updates. So the sample will show you how to get started and do this. And all you need is just an MT3620 development board.
Cool. Awesome, Tyler. Well, if you want to get to that blog post Tyler just mentioned, it's aka.ms/Azure Sphere Power Down. Pretty straightforward. Tyler, thanks for joining the show today.
Yep. Thanks a lot for having me. Appreciate it.
Thanks, everyone, for watching, and see you soon on the IoT Show. Bye.